Hi guys, today I want to talk to you about time constants. You need to understand time constants as we study capacitors and inductors, and in calculating in understanding the various responses that we see. In this case, we're looking at capacitors and the amount of time for a capacitor to reach its full charge. You may recall from the video that a capacitor is going to store the total source voltage that has been applied to that. So when looking at that charge time, the amount of time it reaches that full charge, time constant is 1/5 of that time, or the amount of time it reaches 63.2% of that full 100% charge. So in our case here, if we had a 1 volt applied to let's say a 1 farad capacitor, and we're running it through a 1 ohm resistor, our time constant is calculated by taking the resistance times the capacitance, giving us a time in seconds, and then to figure out how long it's going to take in totality, we multiply that by 5. So using that example, if we had 1 ohm times 1 farad, you have 1 second. 1 second would be the amount of time to reach 0.63 volts, 632 volts in that 1 volt charge. If I multiply that 1 second times 5, it will take 5 seconds for my 1 farad capacitor to charge to 1 volt over a 1 ohm circuit. And equally, it will take that same amount of time to discharge from 1 volt all the way down to 0, an inverse curve. I have this window here to kind of show that same effect. We see it charging 100% voltage-wise, and over that same time period, the current will drop in an inverse curve. So the time constant for the current and for the voltage is going to be similar. Again, that's derived from this equation: resistance in ohms, capacitance in farads. Taking the product of that gets 1 time constant. There are always going to be 5 time constants. It's an integral of 5 for that curve. So you take your time constant times 5, and that's the amount for it to reach a full charge. In Lab 25, you need to understand this is you're taking a 10 k ohm resistor, and let's just call that 10,000, and you're multiplying it by a 0.1 microfarad capacitor. So 0.1 microfarads is I think it's a 0.01, might be 0.1. 0.1 would be 0.123 zeros, 4, 5, 6 zeros, plus the 1. That's a 0.1 microfarad capacitor. And that tells us it's going to have a time constant of 0.001 seconds. That is also 1 millisecond, or 1,000th of a second is 1 millisecond. So that's my time constant. Therefore, if I multiply that by 5, it's going to take 5 milliseconds for it to completely charge and completely discharge in that lab there. You could do that same math using K and micro. We can cancel some things out. So 10 K ohm times 0.1 microfarad equals 1 millisecond. So same way of doing the math, but as we've talked about with resistors, we have some cancellations there with the K and the micros. And if you can remember that, then that's another way of working through it. So 1 millisecond is our time constant. Don't forget to multiply it by 5 because you have 5 time constants. So 5 milliseconds is the end product there. Hope this gives you a little better understanding as you approach Lab 25.